So that's our basic exercise, folks. And it will help us to understand time value of money and discounting. For the whole exercise, we will assume that the cost of capital is 15%. Find present value at T0. The first problem or question is, what is the present value of the total amount if you receive £100 at T1 and £125 at T2? Let's go to our Excel. So first of all, I'll put cost of capital is 15%. Then I will have my timeline, time 0, which is now, today, T1 after 12 months, and T2 after 24 months. You can write down year 0, year 1, and year 2 as well. That's another way of doing it. The question says that received 100 and 125. The total amount you're receiving is 225. The question is asking, what is the value now? Because it is going to be less. To calculate the value now, all we have to do is multiply these values with the discount factor under the relevant cost of capital and along the relevant year. So let's go to our present value table. So first thing to highlight is 15%. Okay. Then after year 1, the value is £1 is 0.87, and after year 2, the value of £1 is 0.756. We pick these values and we type these here. Factor at 15%. .87 and 0.756. We will multiply these two values. So this 87 actually should be here. Here. Value of £1 received £100. So value of £100 received after 1 year is £87 now. Value of £125 received in 2 years' time is 94.5 right now. We add this up and we get our PV. Now I have a question for you because we have 100% understanding. Was this an annuity?
No.
No. Good. Can you explain why?
So it's not a receivable. So I think as annuity means it goes up in value.
The other way.
Yeah.
It needs to be the same amount. An annuity is a receipt of the payment or receipt of the same amount every year. So this is not an annuity. So we could not use a PV table. Look at question number 2 now. £100 received at T1, T2, and T3. Let's put it down on our Excel. Let's put the discount factors. .87, 0.756, and the third one 0.658. We sum it up and we get 228.4. We received £300 in total in 3 installments, yearly installments, but the real value of those £300 is £228.04. We have used present value table to do this and did it a longer way, but we shouldn't be doing it this way. We should be using an annuity table because it's an annuity. It could be done both ways, but it's quicker to do by using annuity table. So let's do it the quicker way. And for that, received okay, let's go to our annuity table. 15%. Pay attention please, important. £100 received for 3 years. So we don't ignore 1, we ignore 2. We select 3 and the figure under 15% parallel to year 3. We ignore 1 and 2 data. 2.283, we calculate received 100 for 3 years. PV, okay, discount factor or annuity factor. PV is 100 times 2.283. $228.3, which is same as 228.4. This point decimal difference is due to rounding off of these figures. So when you're doing investment appraisal questions, decimal places will always be different because these are actually very long decimal places. They have been rounded off. So that's the difference. So whenever there's an annuity, you will use this method, and if it's not an annuity, you will use that method. First one, the present value table. Question number 3. £100 received at T2, T3, T4. What is the present value now? We are skipping year 1. Let's go to our Excel. Received PV, we are receiving £100. We are going to annuity table. Please pay attention. Under 15% because this is year 4. The timeline ends in year 4. The timeline ends in year 4, so we will pick the figure from year 4. So the figure is 2.855. However, because we skipped T1, we will take away the PV of T1 from this value. And this is 0.870. If we would have skipped 2 years, then we will pick figure 1.626. £198.50. we received £300 again. Just like in question 2, we received £300. In question 3, we also received £300. But the real value or present value of those monies is different. And the difference is because of the time value of the money. 198.5. Let's look at the next one. Every single one is different, slightly different, more interesting. £400 received in perpetuity forever. You will be receiving £100 for the rest of your life. PV 100 divided by 0.15. Simple. Easy peasy. You simply divide the value with the cost of capital. 0.15. And the answer is 666.67. You would say that if you receive £100 every year, after 10 years you would have received 1,000. And after 20 years you receive 2,000. So why the value is so less? Because the cost of capital is so high, the further we go from present, the lesser or fewer will be the value of the money you receive. So after some time, whatever you receive is not important for decision making. It still exists, but it's not significant for decision making. So another example I usually give to students, that if you will be working, like a person like myself, I will be working, if I will be working for the rest of my life, as a salaried person, as an employee, I will be getting whatever money, and I can, if I'm working for another 20 years, my career is total 30%, I can calculate how much money I'm going to make throughout my life. If my salary is 50K, I can do it. And that is the value of an employee or anybody, if you're working. And you'll be surprised that even if you're working at 60, 70,000 per annum, it's less than 1 mil. However, you could say that, okay, today you're getting 50K, next year there'll be slight increment, inflation adjustment, so there'll be a little bit of growth every year. And right now you're making 50, maybe by the end of your career, you would be making 100K or maybe 200K. We can calculate that as well. So let's do that. So the growth. Now we need to incorporate growth into our calculation. £100 starting at T1 to infinity, growing at 5% per annum. They should be per annum there. So we need to adjust this formula, which we have used here, by the rate of growth. So what we do is 100 growing by 1.05. So what I did, 1 plus 0.05. 0.05 is 5%. So I did 100 plus 0.5. So this is, we will multiply our money with the rate of growth divided by the cost of capital, which is minus 0.15. But this too needs to be adjusted for the rate of growth. So we take away the growth value. So if you do 100 times 1.05, 105, and 0.15 minus 0.05, and if you do the maths, 1050. If the growth rate is 10, then it will be 1.1 and minus 0.15 minus 0.1. So we change it with the growth rate. And this takes us to the final one in this exercise, number 6, where we have some random receipts. At T1 is 10, P pence a pound doesn't matter. T2 is 12, T3 is 11, and after that, T3 will be growing by 3% every year. So let's deal with this now. T1, 10, T2, 12, T3, 11, and at T4 is 11 plus 3% to infinity. So we start with discount factors. We have already used these factors. And for the infinity, T4 to infinity onwards, T4 to infinity, we do 11 growing by 1.03 divided by 0.15 minus 0.03 by the growth rate. So we need a bit more calculation here. What did I do? And when we apply this formula, we will have a value a year before. And this is the tricky part. Why at year 4? For this, we need to go back. In this question, the cash flows were starting from T1. We applied the formula at T1 and it gave us the value at T0, 1 year before T1. So this formula, whenever it is applied, it will give you a value a year before. So when you apply this formula at T4, it will give you the PV at T3. Now you need to further take it back to T0 by applying the same discount factor as you did before, and you will have the value at T0. And that is the PV of these values. If you transfer them to T0, $87.1. So this part may need a little bit more thinking.